Day 2 of factoring, we're going to talk about factoring trinomials. Okay, let's break this word apart. Does anyone know what trinomial means?
3 numbers.
3 terms, right? So a trinomial is 3 terms. So the trinomial we're going to be working with is the ax squared plus bx plus c. Have we seen this before? Yes, it's that ABC that we talked about, okay? Just as a little review, what do these squared graphs look like? They're the parabolas, right? They're the U shape, okay? No, we're not graphing, okay? But that is the, if we would graph it, that is what our graph would look like, okay? So factoring trinomials, what's going to happen is we want to find 2 numbers that multiply together to get C and add together to get B. Okay, now that B and C comes from the form up there of ax squared plus bx plus c. So here's our B value, here is our C. Okay, I forgot to label this, okay? This definition right here is for when A equals 1. Okay, that definition there is for when A equals 1. Okay, every example that we see today, our A value or this term in front right here is always going to be 1 for today. Okay, tomorrow we'll look at when it is not 1. Okay, so really today we're looking for numbers that multiply to give us C and add up to give us B. Okay, we did a little bit of this on Friday when we did the intro activity, just not in this form. Okay, but it has the same idea. Okay, so we're just going to look at a bunch of different examples here. So go ahead and write that first example down. We'll do one example at a time. Okay, so we have x squared plus 8x plus 15. Let's talk about this here. What is my C value? 15. What is B?
8x.
Yep. For the values, we really don't care about the x squared and the x. Okay, we just want the number. Okay, so our B is 8. Is our A value 1?
Yes.
Yes. Okay, so like I said, all the examples we do today, your A value is going to be 1. Okay, so let's think about this. The notes that you wrote down is we want 2 numbers that multiply together to give us 15. So let's think about that first. Okay, what are some factors of 15?
5 and 3.
1 and 5.
1, 15, and 3 and 5. Okay, so those are our factors of 15. Now we want to know which of these factor pairs right here is going to add up to give us 8. Okay, I agree. Okay, we can go through it here. Can 1 and 15 ever get us to 8? No. 3 and 5. Yes, okay. Do I need to change these or can I keep them the same?
Keep them the same.
Yep. So,
Would that be what we write as our answer then?
no. Okay. This is a good part of our answer, okay? But to write it in factored form, similar to what we did for our bell ringer here, we want to write it as x plus 3 and x plus 5. Okay. Reason being, okay, same thing with our bell ringer. If we would multiply that back out, we would get back to our original. Okay, same thing here. If I would multiply or FOIL this back out, we would get to our original here. Okay, these 2 x's right here, they come from that x squared. Okay, we know we need 2 of them. That's where those 2 come from. Okay, so to write our answer is x plus 3, x plus 5. Keep in mind, is this the same?
No. What? Yeah.
Yeah, are these 2 the same? They are. Okay, remember multiplication's commutative. Okay, what that means is it's the same no matter what. So, for example, if I take 2 times 5, is that the same as taking 5 times 2?
Yes.
Yes, because for both of these, what do we get? We get 10 for both of these. Okay, same thing here. If I would multiply these 2, okay, both of them would get me back to my original equation there. Okay, so it does not matter the order you write them in. Okay, let's look at another example. X squared plus 5x plus 6. So again, same process. We want to find factors of which one? What do we want to find factors of? The C, which is 6. Okay, what are factors of 6?
1 and 6.
1 and 6. And 2 and 3. Good. Okay. Now, sometimes more than one of the factors work. You just have to make sure that you're having the right signs with them. So, do you agree somehow we could put together 1 and 6 to get 5?
Yeah.
We could. Okay. But do we want to change any of them to negative? No. Okay. Do 2 and 3 work?
Yes.
Yes. Okay. Do I need to change either of them? No. Bless you. Good. So, how do I write my answer if I pick 2 and 3?
X plus 2 and
X plus 2 and X plus 3, or X plus 3, X plus 2. Yep, remember, order does not matter on these. Okay, let's look at some more here. X squared plus 10x plus 24. What do we want to find factors of?
C.
Which is 24. Yep, factors of C.
1 and 24.
Yep, 1 and 24. 2 and
14.
Or 12.
12. 3 and, careful, 8, and then 4 and 6. Again, you can use your calculator to get those.
4 and 6.
Okay, yep, 4 and 6. So go through, what are we trying to add up to? 10, our B value. Can 1 and 24 get me there?
No.
12 and 2?
No.
Yes, but we would have to change it to negative.
We would have to change it, we don't want to. 3 and 8?
No.
No, 4 and 6?
Yes.
Yes, how do I write my answer?
X plus 4 and X plus 6.
Good job.
Other way around. Good enough.
Correct. Correct. Good job. Okay, so when our C and our B is positive, okay, it kind of makes it a little bit easier. You don't ever really have to change anything, okay, all of the time. Sometimes you might. But what do you notice on my next example here? The C is negative. So let's talk about this one. What do I want to find factors of?
10.
Right. I don't want you to worry about the negative yet. Let's just find factors of 10. Okay, so what are factors of 10? 1 and 10 and 2 and 5. Okay, but we do want to remember that we have a negative sign there. What do one of our numbers have to be?
The negative.
One of them has to be negative, okay?
It doesn't really matter.
Correct. So here, we want to add up to get 3. Can 1 and 10 get me there?
No.
No. 2 and 5.
Yes.
Yes. I have to change one of them. Which one?
5.
Okay, I want to talk about this.
Oh, 2.
If I take 2 plus a negative 5, what does that give me? Gives me a negative 3. Is that what we want? No, we want positive 3. So our 2 has to be negative. Okay, how do I write that as my answer?
X minus 2.
And X plus 5.
Good. Okay, because if I would add negative 2 plus 5, that would give me positive 3. Okay. What do you notice about that next example?
The negative and the B side.
Yeah, the B is negative. Okay. So let's think about this one. What do we want to find factors of?
12.
12. Okay, what are factors of 12?
1 and 12.
1 and 12. 2 and
2 and 10. Or 6.
6. Yep. And 3 and 4. Okay, there's our factors. Can 1 and 12 somehow get me to add up to negative 7? No. What about 2 and 6? No. So it has to be 3 and 4.
4 has to be negative.
Okay, if I make the 4 negative, okay, does 3 plus a negative 4 get me negative 7?
Yes.
It gets me a negative 1. Correct. And also think, does 3 times a negative 4 give me a positive 12?
No.
No. So some of us noticed both of these have to be negative. Okay, if I take negative 3 times negative 4, that does give me that positive 12. Okay, and if I add those together, that will get me to a negative 7. So how do I write my answer on that one?
X minus 3 and X plus 4.
Correct. Okay, so sometimes you might have to change one, change both, or change none. You just have to be careful and make sure it works for both scenarios. Okay, making sure it works when you multiply to get C and add up to get B. Okay. How many more do I have here? 2 more. Go ahead and try these 2 on your own or in your groups. Okay, everyone try those 2 and we'll come back and talk about them together. All right, on that first one, what are some factors of 2? Right, is there many options?
No.
No. Okay. How do we have to change 1 and 2 to get us to negative 3?
Have to be negative.
Both got to be negative. How do I write my answer there?
X negative
x minus 1, x minus 2. Okay, last example for this type of factoring. What are some factors of 9?
1 and 9.
Oh.
3 and 3.
1 and 9, 3 and 3. A lot of the time last year that I noticed, we sometimes forgot that this can happen. Or when you multiply the same number together, those are actual factors. So just remember that, okay? Can 1 and 9 get me to 6? No. 3 and 3. Yes. Do I need to change any of them?
X and 3, x plus 3,
Yep, x plus 3, x plus 3. Does anyone know how I can simplify this more?
Put it to the second power.
Bingo. Okay, these two are the exact same. Do you agree?
Yeah.
Exact same. So I can write this as one quantity, x plus 3 squared. Okay, I would accept both of these. Okay, but just remember, you can have that. What's that?
I like the first one better.
All right. Okay. Factoring by grouping. Okay, factoring by grouping. Okay, I'm going to map this out for you in steps for when we use factoring by grouping. Okay, so when you have factoring by grouping, you're going to start off with 4 terms. Okay, in every example we've seen so far today, it's been 3 terms. Okay, so factoring by grouping is when you have 4 terms. Okay, with that 4 terms, you are going to group the terms into 2 separate groups. Okay, from there, you are going to find the GCF. What's GCF stand for?
Greatest common factor.
Greatest common factor of both groups separately. Okay, and then obviously our end goal, the last step is going to be to factor. Okay, and then we know that as by taking out or dividing, however you want to think about it. Okay, so factor by grouping is when you have 4 terms. You're going to group the terms into 2 separate groups. You're going to find the GCF of both groups separately, and then we're going to factor. Okay. So we're just going to jump right into it. Okay, so we have 4 terms. Remember, terms are defined by being separated by an addition and subtraction sign. So we have 4 terms there. So 4 terms, what was the next step that you wrote down that we got to do?
Group the terms into 2 separate groups.
Group the terms into 2 separate groups. So what we're going to do is we're going to take the first 2 and the last 2 and put them together. Okay, group them together with parentheses there. Okay, what was our step 3?
Find the greatest common factor above.
Of each. Yep, so we're comparing these 2 right here, similar to what we did in our bell ringer. Okay, what is a number that goes into both 4 and 8? 4.
It's the biggest number. It's not the only number, but it's the biggest.
Oh, correct. Yep, so 2 could also go into that, but we want the highest. Okay, how many x's do they have in common?
1.
Why do you say 1?
Because what was the 1 in front of that?
Yeah, it's the smallest, right? Out of these, we want to take out the smallest one. Okay, so we're taking out 4x. Okay, if I do that, now we're going to divide. What is 4 divided by 4?
2.
1.
1. Okay, 2 minus 1 is 1. So we're left with an x.
And then 0.
Okay, well, careful. What is negative 8 divided by 4?
Oh.
2.
Negative 2, right? What happened to this x?
And just cancel that
It
out.
goes away.
It's gone, okay? So we're done with that first group. Now we're going to do the same thing for group 2. So for this group 2, what is a factor that goes into both 5 and 10? 5. Can I take an x out?
No,
Why not?
because negative 10 doesn't have an x.
Negative 10 doesn't have an x, okay? So if I take a 5 out, what's left here?
Just
X.
Just the x. What's negative 10 divided by 5?
5.
negative.
Negative 2. Yep, think division. What do you notice about what I have left here?
It's the same.
These right here are the exact same. That is not a coincidence. Okay, these 2 right here should always be the exact same. Make that note for yourself. Those 2 there should always be the exact same. Okay, if they do not end up the same, you did something wrong. You need to go back. Capiche?
Would that be our answer?
No. Okay, so we're really close to our answer. All we have to do is just rewrite it here. So we're going to take what we have as the same. I'm going to write it. X minus 2. And then we're going to take what we have left over. We have 4x plus 5. this right here is my answer. So I took what repeated, and then I took what was left over and put it together. Okay, so that is our whole factor group there. If I multiplied all of this back out, like usual, I would get back to my original equation or terms that I started with. Okay? All right. Let's do another example. Okay, what is the first thing I need to do on example 2?
Separate them.
Separate them how?
Like put them into two groups.
Yep, put them in groups. Yep, this is called the factor by grouping, so we're going to group them together. What do we want to do next?
Find the greatest common factor.
Yes, so in this group, what is something I can take out of both?
The x.
How many?
1.
One of the x's. Okay. What is left if I take an x away from this?
There's
X, and then what's left here?
3.
The 3. So we have x plus 3. Okay. What can I take out of the second group?
2.
2. Can I take out an x?
No.
No. Okay, so if I take out a 2, what is left?
X.
X.
plus 3.
Yes. How do you check if you did this correctly?
If they line up.
These should be the exact same. How do I write my answer?
So can we just
X plus 3 and then
X plus 3, and then write what we have together, x plus 2. What was your question, Zoe?
nothing?
Are you sure?
Yeah.
Okay. All right. Go ahead. Try that bottom one on your own. I'll give you about a minute here, and then we'll go over it together. What's the first thing I need to do on this one?
separate them into
Separate them into groups. It's called factor by grouping for a reason. What is our GCF, greatest common factor, of this first group here?
1.
I agree with 1. Okay, what else?
2? No.
1x.
Negative
1x, right? Taking out an x. Okay, so if I take out an x, what is left?
3x plus 2.
3x plus 2.
Okay, so I was right.
Yep. Plus, what do I need to take out of the second group? 5, right?
Yeah.
So I'm going to take out a 5. What is going to be left?
3x
Yeah, 3x
plus
plus
2.
Plus 2. How do you know if you did that right?
they add up.
What do you mean they add up?
Like if they equal the same.
Yeah, if the parentheses are the exact same. So to get our answer, remember we take what's the same? 3x plus 2. And then where do I get the other one?
X
1x
plus
plus
5.
Yep, what's left? X plus 5. Good. Tomorrow we will do our last section of factoring that kind of puts it all together.